or you may call them National Senior Certificate Examinations. This is Paper 2, Mathematical Literacy, May, June 2024. Marks 150, time 3 hours. All right, let's go. The question paper consists of 12 pages and an addendum with 7 pages is included in this question paper. All right, shall use the addendums as we see. We shall need them for question 2.1, 2.2, 3.2, 4.1, 4.2, 5.1. All right, please, as you do your exams, don't forget instruction number 4 is important. Okay. Question number 1. The table below shows a list of explanations and definitions, column B, and mathematical terms and concepts in column A. Table 1, the terms and concepts with explanations and definitions. Yeah, those was all looked at last year's paper. You can remember this. It was just like this. All right, what do we say? First and foremost, you may look at the terms. 1.1.1, we have circumference. 1.1.2, probability. 1.1.3, 1 hour. 1.1.4, temperature. We say it's temperature. All right, then you can go through the explanation, which is column number. These are the concepts they're talking about, and the explanations are this side. So these are the concepts, and this other side are the explanations. Anyway, time measured equivalent to 600 seconds. 600 seconds. 600 seconds. This could have been what? This is approximately 10 minutes. When you come here, there's nothing like that. So A is not used. The measuring of both hotness and coldness. Okay, this is B. This could be temperature. Okay. The line from one end of the circle to the other end. This could be diameter. It's not there. An equivalent to the mass of a person divided by the height squared. This is not there, but we know it as BMI. The line, this is the diameter. Hotness and coldness is a temperature. That's why when someone's hot, we use the temperature. And also a cold, we use temperature, degrees. Okay, we go to the other one. Is the boundary that surrounds a circular shape. This is circumference. So circumference is E, 1.1 E. They said you should write the number and the letter. So we wrote it in. 1.1.4 is B. 1.1 is E. So we go and see the time measurement equivalent to 3,600 seconds. We write it like this. Yes, indeed, this is what? 1 hour, which is 1.1.3 an hour. How do we call this? Because we remember an hour has 60 minutes. We multiply by 60, we end up having this much. Okay, go. The likelihood that something happens is probability, which is this. So they are complete. So even though H is not seen, but they say the relationship between the distance of the map and the actual distance. This could have been the scale, but it's not there. Okay. Okay, that's finished. We have done that. So those were 8 marks, each carrying 2 marks. 1.2. The 3 sketches below represent the same portion of physical world which is drawn using 3 different scales, A, B, and C in random order. Okay, the scales are given there, the diagrams as you see them. We have sketch 1, sketch 2, sketch 3. All right, we have 1 is to 100,000, 1 is to 25,000, and 1 is to 50,000. All right, name the type of scale used to draw the sketches. This we call them number. We call them number scale. Other people would like to call them ratio scale. You still get the same answer. Interpret the scale 1 is to 50,000. This simply means 1 unit on paper is equal to 50,000 units in real life. That's what it simply means. 1 unit on paper represents 50,000 units in real life. Write down the scale that was used to draw sketch number 2. Now, when you look at sketch number 2, it's really enlarged, like it's this other part of the diagram. You see that this part from here up to there, it's what is drawn. Okay, so sketch number 2, we shall take the smallest, which is B. Why? The smaller the scale, the bigger the image, whereas the larger the scale, the smaller the image. So sketch number B was B, the smallest scale. That's what we take. The smaller the scale, the larger the image, and the larger the scale, the smaller the image. Number 1.3, the picture below shows information boards, the traffic sign, and the distance information board, and the vehicles heading in the southern direction. The numbers displayed next to the names of the towns information board show the distance in kilometers from the information board to the town, to that town. The picture of the information board and the vehicles heading, southern heading. Okay, so this is what we pick, the traffic sign. The traffic sign. All right, we go on and we see the questions. Give the shapes of the information board. Give the shapes of the information boards. They're saying traffic sign and the distance information. Now they're telling us the information board shows the distance in kilometers. So the information board, it's what? It's a rectangle. It's a rectangle. They're telling you, write down the distance a motorist must still travel in northerly direction to reach Bloemfontein. Bloemfontein. So the distance, now we are looking at the distance between this northerly direction. We are facing that side. Northerly direction. So we shall subtract, which is 534 kilometers minus 144. And the answer you get it as 390. Don't forget the units. 390 kilometers. The 120 on the traffic sign board indicates 120 kilometers per hour. This, which is what? This is speed, kilometers per hour. Now interpret the 120 kilometers per hour in this context. Is the speed speed limit on N1. In this context, we've not seen any other, so we say the speed limit on N1. Determine the distance from this place to Johannesburg. We shall go back to the table there. So now the distance we are looking at is the distance between this place here and this place here. This shall still be subtract, which is 3 and then minus 27. 3 minus 27, and you'll end up having 507 kilometers. 507 kilometers. We are saying we shall subtract 334 kilometers minus 27. And the answer became 507 kilometers. State the general direction of Thompson from the information sign. General direction, definitely it's in the north, because we are heading north. And even when you look, this is on N1. Now, if the cars are heading south, that means this other side is this other side is what? North. The cars are heading south. And the board cannot face cars that are going down. It's facing this side, which is the direction. So they're heading north. So the cars are heading south. So the distance, the place is in the north. The length of one side of the road sign is 90 centimeters. Convert the length to meters. Centimeters to meters, we divide by 100, which is 0.9 meters. Don't forget the units. That marks the question. That marks end of question number 1. Let's look at question number 2. Here we use annexures. Annexure. Question 2. Annexure A shows the site map of Bloom Agriculture Show and entrance gates to the showground. The main exhibition halls are named Protea, Daisy, Tulip, and Lily. Protea, Daisy, and Lily. Daisy and Lily. So there we go. We say, write down the gate number for the main public entrance. We shall come to the table here. Main public entrance. Now we are telling us we can hear this check. The first thing you do before you check on the map, use the key. This is the key, and we're looking at the main public entrance. So what we're looking at is number 2. So the answer there will be 2. Say the maximum number of public name, the maximum number of public. Write down the gate number of main public entrance. We are saying number 2. State the main number of public parking areas available. We go back and you see public areas available. Public, these are the ones. So we have this count. So we have 1, we have 2, we have 3. Any other? We have 4. We have 5. So there are 5. 6. Here we have 6. So there are 6. So here we say there are 6. Determine the number of gates used by vehicles. Number of gates used by vehicles. Let's go there and we see. So they didn't say whether entrance or exit, but they are used by vehicles. So we shall come here. 1. We count 1. We count A, yes. 2. Come down here, we come 3, 4, 5, 6, 7. These are gates. I was just checking vehicle, and I will find out. So the answer here becomes direction south, east. So here we shall come and write south, southeast. All right, a layout plan will be drawn of this site map using a scale of 1:8,000. Determine, rounded to the nearest millimeter, the length of the daisy hole on this layout. Remember, when we look at the scenario, here, they already told us the length of this is it, the daisy hole. The length is 65 meters. So they want it, now 65 meters, that's simply it in a actual sense. So they want it on the layout, which is on paper. So simply meaning they've given us 1:8,000, but we have 65 meters in real life. What will it be? Paper. Shall it H? Or we can say it's missing. Put a box here. So what do? You cross multiply, which come the 8,000 multiplies the box and gets the answer as what? So divided by 8,000, divided by 8,000. This goes with that. So the box becomes 8,000. Sorry, 65 divided by 8,000. Of the answer is 0.00812. Remember, these were meters. Also, this would be what? Meters. But they want the answer in millimeters. What we do? Multiply by 1,000. Multiply by 1,000. Multiply by 1,000. The answer becomes 8,125. These are millimeters. So 8,1, and this is the nearest millimeter. So the answer there becomes 8 millimeters. So on paper it's 8 millimeters, and in real life it's 65. Okay. Question number 2.2. One of the exhibitors sells pedal go-karts for kids. The picture alongside, which requires parts to be assembled in order to ride the pedal cart. All right. An extra B shows the assembly instructions aligned in 2 columns. Column A are written instructions in order, and in column B are visual instructions, pictures, not arranged in any specific order. Use an extra B and information above to answer the questions that follow. Choose a picture from column B that matches written instruction in column A. Write only the letter next to the question numbers. For example, 2.2.1 to question numbers 2.2.1 to 2.2.5, e.g. 2.2.6 if it's F, so you write 2.2.6, you write F. All right, let's go and see that. All right, this is it. So we shall write numbers in that other format there. Okay, there are 5 of them. Let me see. Okay, we shall do the corrections down here, but first and foremost, we shall first say what's happening. 2.2.1. Assemble the wheel caps. Assemble the wheel caps. The only thing that you see here, the wheel caps are these ones here. So the moment you see that, this takes C. C is gone. C is taken. C is finished. We come to this. Attach the frame tubing to the pedal mechanism. Attach the frame tubing to the pedal mechanism. So this is E. Look at that. Shows you this is the pedal to the frame. This is the frame. This is the outline that pass by. So we shall say this is E. And the E is what? Taken. Come to this. Assemble the steering mechanism. Assemble the steering mechanism. They are saying insert the steering rod through the hole at the bottom of the frame into the central hole of the bracket. When you take note, it's this one here. This is the rod that's passing through this part. So this becomes D. So we are left with how many options? We are left with around 2 options. All right, this says assemble the front panel and the steering wheel. Definitely, which this one is the one that you see whereby the steering wheel is taking A. It's already put there. So this B is taken, B comes here. And definitely the last one has to be A. The last one has to be A. Okay, in short form, they wanted you only to write the number, which was 2.2.1, 2.2.2. This is what you do in your exam answer book. And lastly, 2.2.5, but they want letters to be here. So we are saying the letters are C, E, D, B, A. This is what you're supposed to do in your answer book. Don't answer them on the addendum. All right, we look at the second question. Second question. The picture below illustrates safety instructions for using the pedal go-kart. Safety instruction picture 1, safety instruction picture 2. Write down an explanation for one of the safety instructions illustrated in the pictures below, in the pictures above. So the first one, when take note, look at it. There's no any obstacle in front of it to be driven on a flat surface. So this is option 1, picture 1. To be driven on a flat surface. Someone else would have said, driven where there are no obstacles. You see, there are no obstacles that can limit its speed. Okay. Then someone who's talking of picture 2, because they say pick 1. So someone who's talking of picture 2, you can say do not drive it or ride it in places with grass, because the grass here will make it reduces its speed. So it reduces its speed. It acts as a resistant. All right, there we go. 2.4. Table 2 below shows the number of horses, small livestock from Free State, Gauteng, and other provinces on the display in blue agriculture show. One value X has been omitted. Okay, let's try the scenario questions. Determine the missing value of X. Now, the missing value of X, it's here. It's from Gauteng. But we have the total number here of this much. Small livestock. Also, if we add here, also here we have, this simply meaning if you add these numbers, you should get that. When you add these numbers, we should get this either way. So the value of x, you would have done it anyway. So someone would have taken the 2,840 minus into brackets the values that are already there. And here the answer would have come. The answer would have become, the answer would have become the answer would have become 340. Another person, the person who took this other option here, you would say 565 minus bracket 163 and 62. You still get the same answer. Please, you pick one option, don't vote. All right. Question number 2.4, write down in simplified fraction form the probability of not randomly selecting a horse from the total number of animals shown in the table. The probability of not picking a horse. So, what do you know what it means? We're going to eliminate the number of horses from our selection. So we come to the table and we see, you know what, how many horses are there? There are 1,600, 1,360. So if you don't pick these, that means you're going to pick the 2,840 and 700, but out of 4,996. So the probability of not picking a horse was supposed to be 2,840 plus 796 divided by the total number of animals, chances that you have there. All right, that's what was supposed to be the answer. They said probability in simplified fractional form. So all you do that plus 796 divided by 4,696. So here the answer became, okay, wait. You add and you put it in a calculator the way it is, and your answer became 90 over 12. This is the final answer, simplified form. And the reason why I'm leaving it like this, simplified fractional form. Okay, a farm, the display where all cattle are kept, is specifically interested in purchasing cattle from Free State. Take it as a percentage probability of the farmer randomly selecting cattle from Free State. Now, take note of these words, specifically interested in purchasing cattle. So we are not going to look at other total animals. We are only going to look at the cattle that we are having. So we shall come down here. We only look at this space here. But of this space, which ones are coming from Blue Mountain? That's what we do over there total here. So we shall say it's 363 over 796. They want it as a percentage multiplied by 100. 363 divided by 696 times 100. And the answer became this round of all right, number 3. Wind turbines are used as an alternative way to generate electricity. The picture below shows how the size of the wind turbines and generation capacity has changed from 1980 to 2005. All right, we go up and you see, you see them. There we go, from 50 kilowatts to 5,000 kilowatts, 100 times more. And as you see, they also grow in the capacity, in the diameter, the the circumference, the radius. Okay, they're telling us not. These are the heights that we're looking at, the hub heights. The hub height equals to the distance from the ground to the middle of the wind turbine's rotor. Now, to the middle, in actual sense, it's the center of the rotor here. For example, this one here, it's 114 from here to here. You see that? Then 5,000 kilowatts power generation of 124 meters diameter of circular made by the rotor blade of the wind turbine. All right, there we go. We shall see this. Write down the amount of power generated by wind turbines with the second tallest hub. Second tallest, actually, they're already in order. Second tallest is this one here. How much power is produced? 2,000 kilowatts. So the answer here was supposed to be 2,000 kilowatts. Give one possible reason why the rotor blade size of the wind turbine from 2005 is larger than the rotor blade size of wind turbine from 2080. Here we can say it's because of innovation and advanced what? Technology. Someone can say it's because of the increased power demand. Power demand, someone would have said usage. You know, these never leave such questions. Give one possible reason. Possible reason. All right. Calculate in meters the maximum height that the tip of the rotor blade of the tallest wind turbine can reach as it turns. Maximum. These are 3 marks. Now, what we need to do, we are looking for this part here. This part here, from there to here. This part here. This is what we're looking for. But then when you take note, because if it comes here, it's the radius. It's from the center to the top. So simply means we're going to get the height from the bottom, which is already the hub height plus the radius of this is the radius. So the answer there is going to be 114 plus 124, don't forget that's the diameter, divided by 2. And the answer becomes, the maximum height. So we are saying 114, that's the height from bottom to the center, plus 140 divided by 2. Why do we divide by 2? We're looking for radius. And the final answer becomes 170. These are meters. All right. All right. Okay. Anam says that the area covered by the rotor blade of the tallest wind turbine in motion is 12,077.748 meters squared. Verify with calculations whether or not the statement is valid. Now, first and foremost, when we look at them up here, we're going to cover the area, this shaded part. And we look at it, it's a circle. So we shall say area of a circle, it's pi r what? Square, which is the same as 3,142 times. But what is our radius? Our radius is 62. So we bring 62 here and we square. Indeed, we come up with the answer as 848 meters. Yes, the change is only here, whereby if we are to round off, it will become meter squared. So the statement is what? Valid. The statement is valid. The statement is valid. Determine the percentage increase in power generation from 1995 to 2005. What we're going to do, whenever you say percentage increase, in other words, you're looking at percentage change. So we shall always get the new minus the old over the old times 100. So in 2005, we have 5,000 kilowatts. In 1995, we have 800 kilowatts. So divide by that, and we multiply by 100. The answer became 525%. It has increased 5 times. 5 times. Here we go. 3.1.6. Give one other possible source of generating electricity. One, someone can talk of thermal. Thermal we use heat. They burn rubbish and it produces electricity. This is used in Pakistan and Indonesia. Here in South Africa, we can use solar, another source of electricity. This comes from the sun. We can use water, which is called the hydro. This one comes from water, but from the waterfalls. You understand? Source of electricity. Other sources of electricity apart from wind. Wind and solar, these are renewable. Okay, we come to question number 3.2. A completely rectangular base composite box is made up of 3 sections sharing same common panel boards. The sections are assembled by slotting panel boards into panel posts. They are constructed using panels into putting them into all right, we shall go and check the annexure. This is what we are looking at. Okay. So they're telling us, so annexure C shows a rectangular composite box, this one here, and composite box linking section A, B, and C with same common panel boards. Some dimensions of the composite box are also shown. You may use the following formulae where applicable. Perimeter of the rectangle equals to 2 into L plus width. Volume equals to length times width times height. 1 meter cubed equals to 1,000 liters. Annexure C and information above. Use annexure C and the information above to answer the following question. Get the perimeter of the base composite box. So now perimeter in your head, you already have told it's a rectangle. You're looking at the base, still takes a rectangle. So in your head, you know perimeter will equal to to that much. All right, 2 into L plus with A plus W, which is this. But you have a task ahead of you of what? Looking for the length. Let's go to the next and we see. So the length will be this from here up to there. That's the length. So we are going to do what? The length will be 2,3 times 3, which is 6,9 meters. So this is the length. And the width is already what? 3 meters. So the perimeter of the base, that means you're going to move here. You move there, you move again that side, you move again this side. So which is the same as perimeter equals 2 into L plus W. So the 2 into 6,9 plus a 3. The answer here becomes, the answer there becomes 6,9 plus 3 times 2. We've got the answer as 19,8. Don't forget the units. These are meters. The only task that you have to do is to identify the length. All right. So we are saying here that the length, we took the 2,3 meters, multiplied it by 3 because it was they are all equal. Okay. The answer became 19,8 meters. Don't forget it. The boxes of section A and section C were completely assembled. The box in section B fits in between section A and section C, has fewer front panels, boards 6, 7. So if you're to complete this part here, we also need 1, 2, 3, 4, 5. How many are missing here? How many are missing? There are 2. We shall come here and we say 2 panels. Okay, we come to this. At the maximum height of the decomposing composite matter in each section is C to B to A is 3:5:7. Section A, okay, determine in liters the total capacity for decomposing matter in section A and B. Now, what we're going to do, it's measured in volume, and they're saying in liters. The measurements you have there are in meters, all right? So we shall come back and we see. Okay. So now here we're going to determine the volume. We shall first and foremost because they are saying it's B is to C is to B is to A, which is 3:5:7. All right, that's the ratio. CBA 357. So we need to know how much composite is going to be needed. But the easiest to find is to find the section A. Why? Section A is complete. It has its full measurements. It has the height, it has the width, and it has the length. So volume of A, we shall look for volume of A first, which will be, the reason why I'm looking for volume of A, I need to know the total decomposite that's needed. So we shall say V equals to L times B times height. This is the same as 3 times 2,3 times 0,5. Get the answer? So we have 3,4 meters cubed. We want this in liters. We want this in liters. So we shall multiply by 1,000. So we shall end up having 3,450 liters. This is only A. So if you find out the total decomposite that's going to be used, we shall need to ask ourselves, if let's say we have C, D. So now A. Let me see. Yeah, sure, I'll do that one. Okay. We need to find out how much are they sharing. So we ask if A, which is you add this up, you will get 15. So out of 15, take 7. So 7 out of 15 times the total composite, we call it T. They got 3,450. So what is the total decomposite here that we're looking for? So we look for the T, which becomes 3,5, 345 times 15. You end up having. The reason why I'm multiplying by 15 because I need to remove 15 from here. That I remain 7t. So I divide through by 7 to get the value of t. So the total decomposite here is 7,092,86. These are liters. So if you're to look for B, now B is easy to get. Let's find the value of B. So now the value of 392.86 cents. Mm. 92.86. So B is 2464.9. These are letters. So we've seen A, it has taken this much. And the B takes that much. That's what they wanted you to look in the liters. One, look for the volume of A. Two, find out which portion does it cover. In that you find the original value. Original value. All right. Then you find the value of B. Someone else would have done the value of B. If you're looking for value of B, the value of B, you would have done it forward without putting the 15. Remember, it's like this, but already we've got B is missing. B5 should equal to 3, 4. This is the value of A, but over 7. So you can just multiply, you find out that it's 7B equal to 5 times 3, 4. But you're looking for B, so you divide by 7, divide by 7. So the value of B still becomes the same answer. Which is 2464.29. All right. We go to question number 3.3. 3.3. If a temperature rises above 70 degrees Celsius, the composite will sterilize itself, meaning kill the good microorganisms. Convert the temperature to degree Fahrenheit. Now they have given the formula which is upside down. It's fine. Get this formula here, substitute the way it is. What is the C? You put the 70 there. Giving me 5/9 brackets. The F is still there. Because this is a 9, I need to multiply 9 on both sides. In that this goes with that. remain with 9 times 7, you end up having 630, right? Giving me 5 into bracket, the Farana height minus. I want to remove this 5. I'll divide through by 5. This will die with that. And I will end up having 126 equals to F minus 32. I want to remain with F. So this 32 will come this side, becomes, I will add on 32. And the answer there becomes 158 degrees Fahrenheit. That's how we do it. Question number 4. Anda is a teacher in Zimbabwe. Next year, this shows a detailed layout plan of the school building where he teaches. Use the information in the next year, D, to answer the questions that follow. Write down this in simplified form, the ratio of the number of single doors. Take note of that. We are looking at the ratio of number of single doors to the number of double doors. So your ratio should be, look at the next year. This is how the next year looks like. Let's reduce it a bit. It's fine now. This is 4.1, and next year D. Double doors. You can start counting by counting double doors, or you can count all doors and you find out. Anyway, let's count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 26, 27, 28, 29. We have a 30 there. We see this out and we see. See? We have a 30 there. And 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 26, 27, 28, 29, 30. So we have 30 single doors. Single doors, we have them as well. What about the double doors? The double doors are these ones here. We have 1, 2, 3, 4, 5, 6. We have 6 double doors. 6 double doors. So 30 is 2 to 6. So simplified form by, okay, this will be 1. 5 is to 1. That's a simplified form. 5 is to 1. If there are 5 single doors, we have 1 double door. That's what simply means. By the double doors, you see them there on music rooms, whereby it might accommodate a lot of people. Art room, also it could accommodate a lot of people. Then we look at the computer lab. It can accommodate a lot of people from different sectors, like people from different subjects might come to do their research, Meet. All right, that's how we get the ratio, simplified form. So we are saying we have 30 doors, single ones, is to 6, and this became 5 is to 1, simplified form. Name the double doors that, the rooms that have 2 double doors and 1 single door. 2 double doors. Let's look at the computer lab. It has this. It has this. And 1. So the computer lab qualifies. Two double doors and a single door. Then we have the reading room. The reading room there are 2 double doors here and a single room. So there are 2 rooms. One, we have the computer lab, and the reading room. Set one feature that indicates that the school has more than one level. These are the stairways, the stairs. These definitely, if it's one, if it's single floor, we can't have stairs. So this the stairs. Okay. During an evacuation drill, undertook the following route: exited from the room and turned left into the hallway, went right past 3 single doors on the left and a fire extinguisher on the right. Let's first do that. We are looking for 3 doors with a fire extinguisher on the right. The person turns left. 3 doors and the extinguisher on the right. 3 doors, fire extinguisher on the right. 3 doors, fire extinguisher on the right. All right, first and foremost, I think you could first identify where the fire extinguishers are. Their tailors of fire extinguisher will look like this. So we should come and check. We have one here. We have one there. There's something here. There's another one here. So if the person is to exit and it's single doors, the person exits and 3 single doors. So he exits, turns left. Now, if you exit here, you turn left here. Yes, you take this side, but how many? 3 single doors. And you see, you come over here. Anyway, we shall see the story. Okay, 3 single doors in here. Exits, fire extinguisher on the right. 3 single doors. This one, the number of doors are not coming up there. Here, there's nothing. We can't come. We can't be here. The possible answers are here. The possible answers are here or here. All right, let's go back and we see. So exit the room, turn left into the hallway. Okay, past 3 single doors, fire extinguisher on the right. Turn right at the end of the hallway. Past 2 rooms, each having double doors. Another hint is here. So when you go here and you turn right, because if you turn left, if you're from this room, you turn left, you pass 1, 2, 3. But then you've not yet passed them. 3 doors and extinguisher on the right. Yes, here, but are these 3? Okay, it's fine. But when you reach here, you turn right, there are no double doors. That means also this one dies. So we are here. Person could have jumped out of this, turn left, which is true. He comes, he passes 1, 2, 3. The fire extinguisher is on the right, which is true. He turns right. Definitely here you turn right. A single door, then he exits. So from which room is he from? Definitely was from the staff room. It was from the staff room. The laboratory floor needs to be retiled. The dimensions of the tiles that way to be used are 600 millimeters by 600 millimeters. There are 5 tiles in a box. There are 5 tiles in a box. The sketch and the inner dimension of the laboratory floor are below. This is it. So the moment you hear the story like this, meaning you're going to look for the number of what? Number of tiles. Number of tiles. The dimensions of the tiles that will be used are 600 by the, these are 5 in a tile. Okay. All right. Good. 10 marks. The science teacher claimed that they would need a minimum of 40 boxes of tiles. Science teacher claims that they will need a minimum of 40 boxes, simply meaning the starting number of boxes to be bought are supposed to be what? 40. Maximum, we don't know, but it's 40. Okay. That means we can need more than 40. That's what the person simply means. So let's find out. Remember, how do we get the because here we need to find the number of tiles, and again we put them in boxes. So I'll use this space here a little bit. So number of tiles, we shall say number of tiles will equal to the area to be tiled divided by the area of only one tile. The measurements here are in meters. The tiles are in millimeters. What are you going to do? Change these measurements to meters, in that the area of one tile will be 0.6 times 0.6, which is 0.36. Now these are meters what? Squared. Area of only one tile is going to be that much. So that's done. Then what about the area to be tiled? So the area to be tiled, we're going to look at it like this, because this is not a regular shape. So we divide it into 2. I would not advise someone to divide it this way because it will make you work too much. All right, you can divide them going downwards. Divide it going downwards. So this is A, and this will be B. All right, let's look for this area here now. Area of A will equal to L times B, which is the same as 14 times 3,5. This 14 times the 3,5. So this is the area of A. The answer becomes 49 meters what? Squared. Now you go ahead, look for the area of B. Area of B. This is the area of B. Area of B still, it's L times B, which is 3, sorry, let's take the length, the normal length. The length will be 11. This 11 that you see here times 3,5. Where do I get the 3,5? Because from here up to there it's 7. Yet half of it is 3, it's on A. That means whatever is remaining from here up to there, it's also 3,5. So multiply, you ended up having the answers 38,2 meters what? Squared. So we have the area there. Then we come and say the total area now will equal to area of A plus area of B, which is 49 plus 38,2. When you add these two, we are saying the total area to be tiled equals to area of A plus area of B, which is 49 plus 38,2. 49 plus 38,2. We got it as, so area to be tiled is what? 87,2. Now here we go ahead. Number of tiles, we shall say area to be tiled divided by this area of only one tile. When we want to find out how many tiles, divided by 0.6. You get the answers 242.2. Remember, these are tiles. You can't buy a half a tile, but this simply means you will need more than 242. So in other words, we need 243. So these tiles, pack them in fives because they are not sold one. They are sold in a box which has five. So want to find out how many boxes. So we divide it by 5. Indeed, the question here goes to 40. Remember, they are to buy full boxes. So simply meaning 49 what? Boxes. And your conclusion has to be his claim is what? The claim is valid. The claim is valid. The claim is valid. The claim is valid. Point 2, Anda uses a strip map in Annexure A to plan his travels. Annexure A shows the strip map of the roads connecting Zambia to South Africa. Use the Annexure A to answer the questions that follow. Write down the total number of countries shown on the strip map. Total number of countries. We go to the strip map. Yeah, this is the strip map that we're looking at. Okay, total number of countries. 1, we see Namibia. 2, Zimbabwe. So any other? Wow, we can't count Zimbabwe again. It's already there. So we see South Africa and we can see what? Botswana. So many countries do we see? Here you come and say 4 countries. Name the town that's 403 kilometers from Bulawayo. First and foremost, identify where is Bulawayo. Identify where Bulawayo is. So this point here, it's Bulawayo. And you're looking for 403 kilometers. So the town there is supposed to be that one there. The town here was supposed to be Narale. He reached his friend. The formula speed to distance over time might be used. Now here the main thing that we're looking at is what? At what time? At what time? So simply meaning we need to determine at what time was it traveled? At what the speed? How much did he spend on the road? So we need to find the distance between Victoria Falls and Bulawayo. Sorry. And he traveled from Victoria Falls to Bulawayo and he picked a friend from Uruguay before reaching Bulawayo. And they left Victoria Falls at this much. All right, let's go and analyze this. Is from here. It's coming to the place here. Afterwards, they will end here. He picks a friend from there. He picks a friend from here. So we need to know the total distance traveled. So from there to here, what's the total distance? So we shall say 13 minus 520, 552. Let's do that. So he has traveled, but then he goes to the national park. Now the national park, when he picks a person from the national park, let's see, he traveled from Victoria to Bulawayo. He had to pick up a friend from Ingwe National Park before reaching Bulawayo. And they left Victoria Falls at this much time and traveled at an average speed of 2. Okay. Determine the nearest minute at what time he reached his friend. Remember the friend. The person is traveling from Victoria Falls to Bulawayo. He had to pick a friend from the national park. Before reaching Bulawayo, and they left Victoria Falls at this much time and traveled at an average speed of 97. Where he's going to pick the friend. Now they're asking, determine to the nearest minute. At what time did he reach his friend? His friend is not in Bulawayo. The friend is in Igwe National Park. All right, that's where our mathematics has to stop. Eh? At what time did he reach the friend? So it did pass it. It just passed through. So we move up to there. So we have 116 plus the 18 because he's going inside. So add on the 18. He traveled a distance of 179 kilometers. So we've got the distance. How did you get the distance? Find the distance in between these two. Find the distance in between those two. Plus the distance that you've traveled going inside the national park, off the national road. That's why I'm adding on the 18. So the distance is 17 kilometers finished. Then we say our distance now 179. These are kilometers. Okay. Then remember we are determining time. At what time did he reach his friend? So we find out at what time it. So remember very well this formula here, the triangle. I'm showing it to those ones who can't interpret this. So we are looking for time. So we shall say time equals to distance over speed, which is 179 divided by 97. 179 divided by 97. So this answer here became 1,8454. These are hours. So simply meaning he has spent a full hour. And this other one which is remaining, which is 0,8454. These are hours, but you want them to be in minutes. We multiply by 60. So this means that he has traveled 50 what? Minutes. Or 51 minutes. 51 minutes because you round up. So at what time does he reach? If he left 9:55, so we shall say 9:55 plus 1:51. This comes in 6. 10, you remain with 4. You go with the 1. So this other side is what? So he reached at 11. Calculate the total distance he traveled from Victoria Falls to Bulawayo. Total distance Victoria Falls to Bulawayo. Now the story has changed. Total distance from, so but they are saying from, but anyway, it's fine because there are two answers there. If you think like either way you think, first and foremost is from Victoria Falls. He has come here. All right, he has covered a distance. Plus, now he goes, he picks a person, he comes back. That's what we add another 18 because he has to go in 18. He comes out 18. Then he continues with the journey. Now the journey from there to here, this is what we are adding on now. Because he comes back, he joins the road here. He continues to Bulawayo. So it's 55 minus 263. 552 minus 263. We get the answers 289. These are kilometers. Remember, now the total distance will be 179 plus another 18 plus a 28 in the scenario. So in other words, he has traveled a distance of what? 486 kilometers. That's if we were to do like that. Another one, someone would say from Bulawayo from Victoria Falls to Bulawayo. What distance is there? You take 713 minus 263. 713 minus 263. You get 450. Add on the 36. The 36 comes from 18 in, 18 out. So it becomes still. If the scenario is like that, because remember, from Victoria Falls, he didn't go straight to Bulawayo. He went to the national park. And the reason why I've answered it that way, because this section here still is under the same scenario here. He travels. So this is part A, part B. Hence, the answer. All right. Look at question number 5, the last one. Okay, Boltley owns a 4-story building with 8 similar apartments, which she rents out. An next F shows the layout plan of the ground floor of the 4-story building, showing 2 apartments. All right. So each floor has 2 apartments. This could be the main entrance here. This could be the main entrance. They enter, they divide each other. Anyway, let's go to our next one. You see? How it looks like. Okay. This is the floor. Actually, these are 2 apartments when you check it very well. Bedroom 1, bedroom 2, bedroom 2, bedroom 1. They look alike. All right. And in between, these are the stairs. These are the stairs. Anyway, let's continue to see. The total exterior length of the building is 58 feet. Use an extra F and the information above to answer the question that follow. Write down the number of enclosed balcons in the building. Balcons, building. Definitely will go to the, but then write down the number of enclosed balcons in this building. Now remember, there are 4 storage. There are 4 of them, and each has 2. So they could be what? 8 enclosed balcons. Why am I saying 8? Because okay, enclosed balcony. They said this one here is a plan, the layout plan of the ground floor, like first floor of the 4-story building, the ground for the first one. So if the first one has an enclosed building, definitely all of them enclosed balcons. Right, so we are saying 4 of them times 2. Wait, yeah, 4 of them times 2, you get 8. And each has, because all in all they are flats, each has 1. So there are 8 balcons. There are 8 balcons. This is flat number 1 or flat number 2, but 4 times. So there are 2 times 4. You go upwards. 2 times. Okay, let me see. Okay, we have 1, 2, 3, 4. Yeah, 1, 2, 3, 4. So there are 8. There are 8 balcons. For the one side, for the other side. Okay, calculate in faith the missing value of A, 5 marks. Now, this one, we shall take it this way. You see, they said all dimensions inside the building are minus length. call them National Senior Certificate Examinations. This is Paper 2, Mathematical Literacy, May, June 2024. Marks 150, time 3 hours. All right, let's go. The question paper consists of 12 pages and an addendum with 7 pages is included in this question paper. All right, shall we do the addendums as we see? We shall need them for question 2.1, 2.2, 3.2, 4.1, 4.2, 5.1. All right, please, as you do your exams, don't forget instruction number 4 is important. Okay. Question number 1. The table below shows a list of explanations and definitions, column B, and mathematical terms and concepts in column A. Table 1, the terms and concepts with explanations and definitions. Yeah, those was who looked at last year's paper. You can remember this. It was just like this. All right, what do we say? First and foremost, you may look at the terms. 1.1.1, we have circumference. 1.1.2, probability. 1.1.3, 1 hour. 1.1.4, temperature. we say it's temperature. All right, then you can go through the explanation, which is column number. These were the concepts they are talking about, and the explanations are this side. So these are the concepts, and this other side are the explanations. Anyway, time measured equivalent to 600 seconds. 600 seconds. 600 seconds. This could have been what? This is approximately 10 minutes. When you come here, there's nothing like that. So A is not used. The measuring of both hotness and coldness. Okay, this is B. This could be temperature. Okay. The line from one end of the circle to the other end. This could be diameter. So it's not there. An equivalent to the mass of a person divided by the height squared. This is not there, but we know it as BMI. The line, this is the diameter. Hotness and coldness is a temperature. That's why when someone's hot, we use the temperature. And also a cold, we use temperature, degrees. Okay, we go to the other one, which is the boundary that surrounds a circular shape. This is circumference. So circumference is E. 1.1 is E. They said you should write the number and the letter. Please. Yes, indeed, this is what? 1 hour, which is 1.1.3 an hour. How do we call this? Because we remember an hour has 60 minutes. We multiply by 60, we end up having this much. Okay, we go. The likelihood that something happens is probability, which is this. So they are complete. So even though H is not seen, but they say the relationship between the distance of the map and the actual distance, this could have been the scale, but it's not there. Okay. Okay, let's finish. We have just done that. Those were 8 marks, each carrying 2 marks. 1.2. The 3 sketches below represent the same portion of physical world, which is drawn using 3 different scales, A, B, and C, in random order. Okay, the scales are given there, the diagrams as you see them. We have sketch 1, sketch 2, sketch 3. All right, we have 1 is to 100,000, 1 is to 25,000, and 1 is to 50,000. All right, Name the type of scale used to draw the sketches. This we call them number. We call them number scale. Other people would like to call them ratio scale. You still get the same answer. Interpret the scale 1:50,000. This simply means 1 unit on paper is equal to 50,000 units in real life. That's what it simply means. 1 unit on paper represents 50,000 units in real life. Write down right from here up to there. It's what is drawn. Okay, so sketch number 2. We shall take the smallest, which is B. Why? The smaller the scale, the bigger the image. Whereas the larger the scale, the smaller the image. So sketch number B, it was B, the smallest scale. That's what we take. The smaller the scale, the larger